So again, I welcome you all in this video. In this video, we will see the second case of the step-down chopper with RLE load. The load is RLE, but here the conduction in the output current is discontinuous. So this is very interesting. Okay, let's say this is the supply voltage and this is the chopper switch. And in the previous video, we have seen this is R, L, and E load. This is load is known as DC motor load. This is R, L, and E. And since there is L, so we need to place a freewheeling diode across the load. And this is the chopper, and this is the input voltage. So, what will happen to the load voltage and load current? So, let us draw the all the waveforms here. So, let's say with respect to time, this is the input voltage. Okay, this is the constant DC voltage, and say here we are drawing the output voltage. So let's say this is 0, this is T on, and this is T off, and in this way it is going on. And from here to here it is T. So what will happen from 0 to T on? The switch is on, and all the input voltage is appearing across the output voltage. Now what will happen in the mode 2 from T on to T off? So that we will decode with the help of current waveform. So let's say this is the load current waveform, and from T on to T off, from 0 to T on, 0 to T on, current will gradually increase since L is there and L will store energy. Let's say current is increasing like this. Now after T on, the switch is off. Now this L will discharge its storage energy through this freewheeling diode, and all the energy will dissipated in the R in the form of heat. So let's say this L having a small amount of energy stored in it, and that will discharge within this time. Let's say this is some moment K. So what will happen from here to here? What is the voltage across the load from, let's say this is the K point. So from K to T off, the voltage across load is what? Only E is there. So let's say this is the E, this is the amount of E, and at this moment, this is not T off, this duration is T off, this is the capital T. Okay, this duration is T off. Which duration? From here to here, this duration is T off, and T on plus T off is capital T. Okay, so at capital T, the switch is again on, and the voltage, this supply voltage appears across the load, and it will again from the T on duration, from here the T on duration, then switch is off. So let's say this voltage will continue like this. This is the output voltage waveform which we will have continue. So this magnitude is E, and this magnitude is VI. So and again from here current will increase and current will decrease up to this point like this. So this mode of operation is basically, you can see the I naught is not continuous here. This is known as discontinuous conduction. And if we wish to calculate the value of output voltage, so we can see there are two areas basically, this area and this area. So this area is corresponding to Vi and this area is corresponding to E. Simply we can write it is Vi times of T on upon capital T, because it is appearing over T on time period, and plus the other voltage which we are having, that is the E, and this E is for, let's say this is the capital T and this is K, so we can write T minus K upon capital T. So this is the average value, and the RMS value in the same fashion we can draw the RMS value also. So this is T on upon capital T plus E into T minus K upon capital T. So T minus K, you can use it like this also. Okay, so in case of RMS value, what you need to do, just do the phasor sum of these two. So this is like this one and this one. Because by formula, the RMS value is basically root mean square. Root mean square. So the square of what? Vi into t on upon t, and this function it's square plus mean root plus mean. So by formula, this is the root mean square, and finally we are getting this value. This is the RMS value of the output voltage, and this is the average value of output voltage. Okay, so thank you for watching this video.